So as Carrie alluded, I'm going to talk about a lot of things right now, which is probably why my talk title is so long. I'm going to try to cover integrating legal requirements with scientific understanding, as well as balancing scientific outcomes from the Ocean Tipping Points project with management realities. So you've heard a lot about the scientific side of what we've been doing on the Ocean Tipping Points project. I'm going to broaden us out a little bit, back us up to talk about some of our synthesis work on the management and legal side of things in the first couple of years of the project, as well as how we've actually engaged the management community directly. So, what does the law say? What are managers doing? And how is the Ocean Tipping Points project walking the talk by actually engaging the experts? So, as we heard from Carrie, cliffs are everywhere. The old talk title of this was How to Not Fall Off a Cliff, so hence my cliff metaphor. But the question we asked as a set of the legal team was, do we act like it when we're actually managing the system? So are we managing nonlinear systems in a linear way? Are we managing them as if they are infinitely resilient, like we can just do anything we want and it'll still bounce back? Or are we actually thinking about these nonlinearities when we are practicing under the statutory requirements and the regulatory requirements that our agencies are required to do? So the first thing we asked was, do federal and state environmental laws and regulations actually allow for threshold-based science in decision-making? And spoiler, Carrie kind of killed it for me. Yes, the answer is yes. We have a lot of leeway, but it kind of depends on the law, and it kind of depends on the context, and that also shouldn't come as a surprise. So we looked at the Clean Water Act, the Clean Air Act, the National Environmental Policy Act, the Marine Mammal Protection Act, the Endangered Species Act, and the Magnuson-Stevens Act. And we looked at the laws themselves, and we looked at the regulations that have been put in place by the agencies to implement those laws. We looked at some guidance documents, we looked at some policies, and we asked, okay, if name that manager was given the best available science around tipping points, do they have the authority, do they have the jurisdiction to use that science and manage for nonlinearities? Again, the answer is yes, but it depends on the law. So we took a little bit of time to break down both the substantive provisions of some of these laws and also some of their procedural requirements, so we could start to tease out when we might be able to incorporate certain science in certain situations. So if you're managing water under the Clean Water Act, these are some of the tools and the hooks that we could use, for example. So the first type of substantive law are really actually all about human health. So the Clean Air Act, the Clean Water Act, very much were put in place in the 70s to protect human health. We need clean air and clean water to be healthy humans. Of course, if you have clean air and clean water, that's also really great for the environment too, but they're the sincere drivers, the underlining drivers behind why Congress even put these laws into place was to protect human health. So classic kind of dose response curve work is done under the Clean Air Act and the Clean Water Act. How much benzene is too much for people? How much particulate matter can we handle? And really, those are thresholds. With the Clean Water Act, you also get a little bit of the environmental side. Let's clean the water up this much. And I'll actually get to that a little bit when I talk about the more procedural hooks that are in some of these laws. So another type or grouping of these laws are these single species protection type laws. So we've got the Magnuson-Stevens Act, the Marine Mammal Protection Act, the Endangered Species Act. We're thinking about individual species populations, and we're actually seeing a lot of use of threshold-based science when managing these species, right? So we see maximum sustainable yield under Magnuson-Stevens, or optimum sustainable population levels under the Marine Mammal Protection Act. You know, in theory, if you have enough science, you're actually doing threshold-based management to protect some of these single species. And then the last bucket of law that it was kind of like, which one of these is not like the other, is the National Environmental Policy Act, which can actually look at entire ecosystems and think carefully about if you're doing a project that's going to impact the environment, if it has quote unquote significant impact, then you have to go through environmental review. And so what does that significant impact look like? You could imagine incorporating threshold-based science into that level of significance analysis. So on the flip side, I mentioned that some of these laws have more procedural hooks embedded within them. So I just talked about some substantive categories. These are some actual hooks within the law where you could see incorporating threshold-based science. The first one being really obvious, best available science requirements. These are sprinkled across all of these federal laws we looked at and embedded in all these regulations. So you got the best available science on, name that tipping point. Then you could see a manager having the leniency and ability to incorporate that science into their decisions. Other examples are with the risk versus technology-based standards. These are actually found in the Clean Air Act and the Clean Water Act. Risk-based standards are you must clean up the water to this level because we know the water is bad under this level and you must do it no matter how much it costs or what kind of technology you have on hand, it must be this clean. Versus technology-based standards which say use the best available technology to clean it up as best as you can. So you could imagine the risk-based standards lend themselves much more to thinking about thresholds and tipping points in the system than the technology-based standards. These last two are also found in a lot of these laws, cumulative impacts analyses. This is really at the root, right? Especially synergistic impacts, 1 + 1 = 5 kind of stuff. This is at the root of these abrupt changes in these thresholds that we've been talking about tonight. And cost-benefit analyses, I'm not going to go into right now because we could, spend days, I think. But you can imagine a situation where the manager is, let's see here. Here's your classic curve. And maybe you're here or maybe you're here, and the manager learns that they're here, and they could put this much more effort into not falling off the cliff. If they dedicate their resources, their people, they throw everything at it to keep them here. Versus if they learn they're here, they've already fallen off the cliff. And so the money, the cost to getting back over could be really high. So if you're doing a cost-benefit analysis that is matched to where you are on the curve, you could imagine that having a serious bang for your buck as a manager. So that's the kind of legal review that we did. We actually have added to that list of laws that I listed off there. We've done another 4 or 5, I think, trying to tease out some of those hooks and some of that understanding. But another thing we did, switching gears just a touch, is looking at what are managers actually doing on the ground. We know they have the ability under current existing legal frameworks, but how does this look in practice? And are there certain things that some managers are doing that are giving them great success when they're managing in tipping point systems? And so we actually looked at a range of 51 case studies from around the world, both terrestrial and marine, and we categorized them based on 18 different attributes that ranged from biophysical attributes like location and size of the system, scientific attributes like are they using a defined qualitative threshold in their management decisions, or do they have leading indicators available, other kind of softer enabling conditions like do they have jurisdiction over the key drivers that are driving some of these abrupt changes, and institutional attributes like do they have routine monitoring in place or are they doing adaptive management. And so we ran all of these questions through all of these case studies, and we actually found, and by we I mean my scientific statistical analysis friends, found that threshold-based management actually can work, that in those systems that we reviewed where they actually explicitly used thresholds in management were strongly associated with better environmental outcomes. We also found that responsive monitoring is key, so those systems that actually had routine monitoring requirements in place that were at the time scale relevant to the threshold had greater success meeting their outcomes. And finally, that scale matters. And none of these are actually rocket science, but it was nice to see them come out in the statistics. And so in those systems with smaller geographic areas, they tended to have better success than those that were kind of a larger swath of ocean or coastline that they were trying to manage. So those were 2 reviews that we did kind of early in the project, really just to get our feet wet and say, okay, this is some pretty intense scientific understanding and jargon. What does this look like from the management and legal perspective? The other thing that I've really been a part of with this project is working with these folks. They are our expert management advisory group. There are 9 managers from across the country, but with focus in California. We've got 2 managers each from our case study regions in Hawaii and Haida, and they really just keep us honest. They tell us like it is, and fortunately for us, we've got them. It's been an interesting ride. We've engaged them, as Carrie mentioned, from essentially day one. We've had a variety of in-person meetings and webinars and one-on-one, two-on-one phone calls with them throughout the project, and they are just invaluable. However, we've learned a lot from engaging them, and I'm going to give you a couple of lessons, and I hope that these feed into the remarks that Rod's going to take up with. The first is that understanding and communicating jargon is a two-way street. I think if those of you aren't in the land of tipping points like we all are, you've probably heard some serious jargon tonight, right? We've got regimes and drivers and thresholds and indicators and hysteresis and alternative stable states and all these things that may roll off the tongue for you, but they do not roll off the tongue for the management community. And so we've had a really interesting time, a really interesting back and forth with our managed advisors, basically saying, you guys gotta just say what you mean here because we don't get it. We were just on the phone a couple of weeks ago and they were like, you gotta take the jargon out of those steps. And we were like, oh my gosh, we're still using jargon 3.5 years in. The second is that engagement early and often is easier said than done. Engaging early and often is really hot. Everybody's always talking about how important it is to engage the management community early and often. But when it comes to actually doing it, it is really, really hard. There's a couple of reasons why. One, you don't know what you're doing yet, and you have to get up there and act like you do. 2, the manager's like, you're not telling me enough to really see myself in what you're trying to tell me. I don't really know what's, and so you find yourselves in this place where you're constantly learning and going back and forth, which is really hard, but turns out also extremely beneficial. This is related to communicating research while simultaneously researching is really hard. We use a lot of build the plane while flying it metaphors at the Center for Ocean Solutions, and the Ocean Tipping Points project is no exception. And fortunately, like I said, we have these trusting, honest, very honest managers who are there with us even though every time we don't make a ton of sense. And then the final lesson is that specific applications to the quote-unquote real world are key to communicating and understanding. And so our managers are always asking us to give them examples. Give me another example. What do you mean by that? Give me an example of that. Can I have an example of that? And so we are constantly generating examples. And in fact, those 51 case studies I mentioned we reviewed have come up over and over and over in the project because they're great for us to be able to ground what we mean when we say, this is an example of managing for a tipping point in a coastal estuary. So I will leave you with those. We're still doing all these things with our managers, and we're happy to have them and happy to answer any questions. So thanks, guys.